Lesson 8, rational equations. Lesson 8, rational equations. So we're taking rational expressions, and we have one or more rational expressions, and there's an equal sign. And the instructions will be something like solve this rational equation. In other words, you're finding the value of x, or whatever your variable is, the value that makes the equation true. So an example here could be something like 6 over x equals 6 over x plus 1 plus 1. Right, we have one or more rational expressions. There's an equal sign. The instructions here would be something like solve this. Okay, so let's see what we can do. The go-to approach. You technically could, one way that you could do it would be to take this one, if you ignore that part, this is just like something from lesson 7. You can take this 1, you can multiply it top and bottom by x plus 1, so you can take the 1 times x plus 1 over x plus 1. That will allow you to combine into one rational expression. At that point, you have a rational expression equals a rational expression, and you can cross multiply. That'll totally work. I find it's usually quicker and easier just to multiply everything by my lowest common denominator. So let's start out finding what our LCD is here, our lowest common denominator. X, is that like a multiple or something like that of x plus 1? No, x plus 1 does not use, so our lowest common denominator here is just an x times our x plus 1. Okay? So let's take our lowest common denominator, multiply each chunk by it. What that does is it eradicates all rational expressions. And at that point, we have something just like a linear equation that we need to solve, or a quadratic equation that we need to solve. We're going to take our LCD, multiply by each thing, and all of our denominators should cancel if we do it correctly. All right, let's see what we get. I'm going to grab my brown pen here. Lowest common denominator, x times x plus 1 times our 6 over x equals our lowest common denominator, x times x plus 1 times 6 over x plus 1 plus our lowest common denominator, x times x plus 1 times 1. And I'll make that look more like parentheses. All right, now let's look at what cancels. X and x cancel. X plus 1 and x plus 1 cancel. And there's nothing here with the denominator to cancel. So what happens? X plus 1 times 6, well, 6 times x, that is 6x, plus 6 times 1 plus 6 equals x times 6, or a 6x, plus x times x, get these right, 6 is here, x squared, plus x times 1, or just x. Okay, let's see what we get. I like the fact that I have a positive x squared on this side, so I'm going to throw everything over to this side. So let's see what we get. If I subtract a 6x from both sides, then that would leave me with 6 equals, well, that becomes nothing. So x squared plus x. Now I just need to subtract the 6 from both sides. So minus 6. Oh, if that's a 6, what did I? This was a plus x, I said. I wrote a 6. Plus x plus x. Subtract the 6 from both sides, and I get minus 6, so this becomes 0. I'm going to flip-flop just so it's more how I'm used to looking at it. That will give me x squared plus x minus, I did that again, plus x minus 6 equals 0. All right, now we need to solve this. I could go quadratic equation, quadratic formula, but I can also see if we can factor this. So I'm looking for two numbers that multiply to be negative 6 and add to be 1. So negative 6, two numbers that multiply to be negative 6 and add to be 1. Well, I could look at 6 and negative 1. I know my positive number needs to be the bigger one, so when I add them, I get a positive 1. These do multiply to be negative 6, but they don't add to be a positive 1. 3 and negative 2. 3 times negative 2 is negative 6. 3 plus a negative 2 is 1. So this can factor to be x plus 3, plus 3 times x minus 2 equals 0. So something times something equals 0 if the first thing equals 0 or the second thing equals 0. So I can rewrite this as x plus 3 equals 0 or x minus 2 equals 0. So in this case then we get x equals negative 3 or x equals positive 2. Supposedly we're done, except we always have to check our answer, especially if we ended up with an x squared going on. Because we might have created an additional answer out of nothing. So we have to go back to our original and check our answer. So let's come over here and let's check. And I'm going to start out checking x equals negative 3. So I'm going to take my original thing, plug into negative 3. So I have 6 over negative 3 equals 6 over negative 3 plus 1 plus 1. Let's see, 6 over negative 3, that's negative 2. Equals 6 over negative 3 plus 1, a negative. So 6 over negative 2 plus 1. That's a negative 2 equals 6 over negative 2 is negative 3 plus 1. Negative 3 plus 1, these technically we don't know yet. I like to put question marks over them. And we get negative 2 does equal negative 2. Cool. That answer checks out. I can now box it as one of my answers. Let's check x equals 2. We get 6 over 2 equals 6 over 2 plus 1 plus 1. 6 over 2, that's 3, equals 6 over 3 plus 1, 3, we don't know yet, we don't know yet, we don't know yet, equals 2 plus 1, 3 does equal 3. This one also checks out. So I can box that as an answer as well. The tool here, again, find your lowest common denominator, multiply every chunk by your lowest common denominator. What that will do is it will cancel out any denominators that you have, leaving you with a type of equation that we've been solving almost all year. So that's my approach for this kind of problem. However, if you just had this, let's say, you can just cross multiply. You can say 6 times x plus 1 equals 6 times x. Or if you had this, you could go for a same denominator here, combine, and at that point you can cross multiply. They all will lead you to the same answer. My preference, find the lowest common denominator, multiply everything by the lowest common denominator, and that gets rid of all of your rational expressions. It turns it into a linear or a quadratic. So that's how I would do it.